Good morning. I'm going to real quickly do one of my first videos for the kind of a brief overview of the Unit 2 readings. I'm going to go over these readings right in here, right now, very quickly, and post a video here shortly, and then we'll take off from there. And I want to just cover some of the kind of the concepts I think you should be looking for. And obviously, these are going to be connected to the Atmospheric Layers Lab and the Weather and Climate Online Review assignment coming up. And eventually, the weathering processes and system quiz coming down here. The weathering processes and systems quiz, which is covering these readings right through here. So I'm going to go ahead and get into here real quick and go over these pages with you. Okay. And so it's just a brief overview, as you're going to be trying to understand and learn some of the objectives of understanding how our atmosphere works to control and structure much of the weather and climate around the Earth, and really in particular highlighting the role of the sun in shaping those processes and how the Earth deals with the sun's radiation. When you go to the next page, you start talking about some of the uniqueness and how the things that our atmosphere controls and regulates, and how our atmosphere is often different than other planets, and how certain processes and certain gases in particular, like carbon dioxide and oxygen, work together to control and manage key processes in the biosphere like photosynthesis. And you start seeing that there is a geographic and spatial pattern of how certain gases are not equally distributed, and that, for example, some gases are constant and some are variable. And here's a gas showing you ozone levels, and these different colors communicate how gases in certain areas of the world become more or less because they're variable. And as you then have to understand and see these maps, you'll see diagrams like this, and you'll have to be able to read the map legends to understand that where are the high areas and where are the low areas. So on this map, I know factually that these dark blue and purple areas are areas with less ozone, and that will mean something to you later because ozone is what intercepts and absorbs ultraviolet radiation coming into the Earth, and this is why any animals or any life on Earth or in the oceans near the South Pole at certain times of the year have specific times when there's more ultraviolet radiation hitting the Earth. So this is just a brief overview of some of the Earth's gases and giving you an introduction of the primary gases in the atmosphere and some of their behavior and characteristics that they're associated with. This is a pie chart showing you a breakdown of Earth's atmosphere and what is the primary two gases, which are oxygen and nitrogen, which make up about 99% of the atmosphere, and then all of the other gases make up about 1%. We call those gases the variable gases. And if you were to look at other planets in our solar system, you would see a very different pie chart for almost all of the solid planets, like Mercury, Venus, and Mars, and even the outer planets, the gas giants like Jupiter and Saturn and Uranus and Neptune. Every planet almost has a different chemistry in terms of the composition of the atmosphere. And as we go down through here, not only is the composition different, but the atmospheric pressure is different as well. And this shows you a nice trend line showing you as the altitude increases, how the atmospheric pressure decreases with altitude. So in our atmosphere, we see distinct patterns is depending upon what altitude you're at, the atmospheric pressure changes dramatically. One of your first labs is literally on this diagram showing you how the Earth's layers that control the radiation in and out of our atmosphere from the sun change with atmospheric layers. The four layers or shells they're called is the troposphere, stratosphere, mesosphere, and thermosphere. You will be asked to understand how does the temperature actually tell us and inform us how one layer stops and where another layer begins, and it has everything to do with how radiation is absorbed or transmitted. In layers where the air gets colder, like in the troposphere, versus layers like the stratosphere, it's often to deal with energy from the sun coming into the Earth's atmosphere from space, and either radiation being absorbed or transmitted. And if radiation is absorbed from the sun, we often see temperatures going up. And so these layers kind of give us an idea of how we control the Earth's thermostat. If too much radiation comes in, if all of these layers are absorbing radiation above, no radiation gets below, and the Earth freezes. If all of the sun's radiation gets below and hits to the Earth's surface in the troposphere, then the Earth's surface heats up too much. So this is why we call the Goldilocks planet, is some layers are allowing radiation in, like the troposphere, whereas the stratosphere and mesosphere, they tend to be absorbing layers, and this is what helps us control our planet's temperature being around 59 degrees Fahrenheit. Okay? And they give you, and I would advise you, they give you a little profile of each layer of the atmosphere, the troposphere, and I have a nice little video here, profile of the stratosphere, mesosphere, and the thermosphere. I would pay attention to some of the details associated with each one of these layers, because one of your very first assignments is on understanding what's causing these layers to either cool off or heat up. Just as a reminder, any video on here, I would advise you to watch, because it'll help you understand concepts associated with that topic. Okay? So here's another one on the thermosphere. Once you get this background, and I would strongly recommend you to have this chart in front of you here for the test, is I regularly ask questions about the electromagnetic energy spectrum and the whole concept of energy. And understanding this chart is really very important to understand. These are short waves and these are long waves. This is what visible light is, and this is what the human eye detects, from violet to red, and this is the only part that the human eye sees. This is what the sun emits to the Earth in a variety, and the sun's spectrum is primarily along this area here, between visible light and the X-rays, which we call the short wave. The Earth spectrum is more in the infrared spectrum, and it's important for you to understand how surfaces interact with radiation. For example, X-rays are a good example, is that the human body could either reflect or absorb radiation. Because X-rays are shorter, they actually pass right through the human body, and then they hit bones and reflect off bones and ligaments and tissues, and that reflected radiation off of an object is what we see in our imagery with our CAT scans and X-rays that allow us to diagnose illnesses with humans. With the Earth, we want to know whether radiation is being reflected off of an object, because if it's reflected, it doesn't heat up. If it's absorbed, it tends to heat up. And that's why when we looked at the last section, some layers of the atmosphere are absorbers and they heat up because they're absorbing some wavelengths of radiation. So for example, the ozone layer is very associated with absorbing ultraviolet light, and that's why the stratosphere and ozone layer heats up. So please pay close attention to the differences between temperature and heat. And you will see that temperature and heat are not necessarily the same thing. Temperature is the energy of motion, and heat is the energy moved to balance out the differences in temperatures. So wherever there's a higher concentration of energy in one object, it will transfer to another. It will transfer to an object with lower energy or less kinetic energy. And so heat is the energy that transfers from a lesser state to from an area where there's from a greater state to a lesser state, so that we have more of an equalization or balance. This was what weather is all about. You're going to learn that there are different temperatures around the Earth. The equator is an area where there is much more concentration of energy and temperature. Heat is the weather that moves from the equator to the poles to balance out the differences. The two are interrelated, but not necessarily the same thing. This is energy from the sun, and we kind of talked about this. This is why we kind of saw this in the last unit. We've studied this a bit already. We already know that energy comes to the sun and actually hits the earth in different angles. And it's these differing angles at different times of the year that control the seasons. And depending upon the sun's angle during an equinox or solstice is what determines our seasons with fall, spring, winter, and summer. So one of the key things to understand is that the energy from the sun hits the earth, and some areas simply get more or less energy based upon the angle of the sun. Closer to the equator, places like Brazil, they tend to get more direct energy, and that's why it's warmer there. And areas near the poles, they tend to be cooler because they're getting more indirect radiation, and you get more reflection off of the atmosphere when the sun's coming in at a lower angle. Well, so this is why we have heat moving from the equator to the poles, because there's more of a concentration of energy near the equator. So there's the classic diagrams of the Earth's revolution around the sun and our understanding of the solstices. Our whole atmosphere, as we just discussed, was about heat transfers in the atmosphere, and we typically have to move heat from the equator to the poles, and we typically have to have ways in which heat leaves from the Earth's surface to the atmosphere. More of the sun's energy is absorbed, more of the sun's energy is absorbed at the Earth's surface, and the Earth has to find a way of moving that radiation back through the atmosphere, trying to move it back to space. So we often talk about shortwave radiation in, which is visible radiation, and the Earth trying to push long-wave radiation out. It is the balance of energy in and the push of heat out that controls the planet's temperature. I very well might be adding a lab showing you how this process controls effectively and how you can manipulate the influx of shortwave radiation in and long-wave radiation out to effectively control this planet's temperature. So there's a variety of mechanisms that lessen the amount of shortwave radiation in through reflection, and then there's a variety of processes that control and regulate how heat tries to escape the Earth's atmosphere. And we talk about processes like the greenhouse effect and how heat, long-wave radiation, is caught by the greenhouse gases and redirected back down. So this is something that we'll have more conversations about, but this is the overall process of what controls the Earth's temperature on a planetary scale. So one of our next to last slides here is talking about, once you understand that the Earth is heated unequally, this is what sets up air pressure systems to relocate and redistribute heat from high pressure zones to low pressure zones. And this movement of air from high to low pressure is what effectively equalizes or attempts to equalize out the differences in temperature and pressure across the Earth. So you'll have some diagrams showing you that effectively there is a predictable pattern of why winds move around the world, and certain weather processes that are direct indicators of why certain areas around the world we will see winds moving and shifting by times of year as the Earth establishes a seasonal pattern of high and low pressure systems on a planetary scale to move heat from high to low pressure. So on a planetary scale, this diagram here is kind of set up to kind of show you the different air pressure zones that are established on a planetary scale, and the geography showing you around the world. There are certain areas that are fairly consistently associated with high and low pressure, and these alternating low, high, low, high. This is what establishes our wind belts around the world. And this is why there are certain areas around the world where there's a fairly consistent pattern that we see almost like interstate highway systems of air moving heat around the world to redistribute energy from the equator to the poles. And there is a distinct geography here and patterns of why areas where you consistently find low pressure are often going to be very wet areas. In areas where you consistently find high pressure, you're going to find very dry areas in some of the world's desert systems. And so they kind of talk about that here, and they show you that areas around the world, their ecosystems are often shaped and driven by these patterns. On this section is that there are some pretty consistent winds out there that move in a predictable way, and they migrate seasonally. And there's some videos on here, and they discuss how these weather systems move and migrate, and in particular bring certain types of weather associated. So nice little quick video here for you to watch so you could kind of see how these topics will show you geographically how they're affected. So one is the polar jet stream over the United States, whereas at the equator we have like the monsoon seasons, of how we can see that these air pressure systems do migrate and they are seasonal in nature, and how certain regions around the world the air pressure changes by time of year. So I'm going to stop there and wait to go over the weather processes in the next unit. So if I was to go back to the reading, I'm going to go over these processes here in a later video and post them right underneath here. So you can kind of at least give a general idea of, I give you a sense of what assignments. I'll try to make sure you're aware of which one of these videos are associated with assignments that you might be dealing with down below. So I clearly tell you these readings are associated with the atmospheric layers lab, the weather and climate online review, and then there's a quiz over these sections of readings as well. So I'm going to go ahead and stop that share, and I'm going to end this call so I can keep it fairly short. But that was just a brief overview of the first set of readings on the atmosphere.